Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the PLC S7-200 Smart CPU SR20, send data to PLC S7-200 Smart CPU 20 also by using the Modbus RTU for communication. Okay, so before go to create the program blocks or use the library, I would like to explain the concept a little bit. Okay, so here is the PLC S7-200 Smart that we will set the IP address with 192.168.2.1. So this IP just example. So if we use the step 7 microwave smart connect to the PLC, we can change the IP address to be made with the computer IP address. Yeah. So if we choose the computer IP address rank like this, so we can set the manual of IP address of PLC followed by your computer. Okay, and here is the Modbus cable. Actually this is a Profibus cable, so we can connect from port 0 of PLC 1, example CPU 1, and here is the CPU 2 that pin number 3 is connect with pin number 3, pin number 8 connect with pin number 8, and pin number 3 is plus data, pin number 8 is minus. Okay, so this is a CPU master and this is a CPU slave, so I will create the program and then test step by step. And here is the software that we will use. The first one is step 7 microwave smart. The second one is Windows replaceable smart version 3, and I will use the HMI model 700 IE V3 also to connect with the switch, and then from the switch number port number 1 I will connect to the PLC 2, port number 3 I will connect to PLC 1. So all these ports we can use for communication, yes, with the HMI, and I will set the IP address of PLC 1, PLC 2 and HMI, and also computer follow this step. Okay, so if we set IP address like this, we can ping from the computer to the PLC 1, from computer to PLC 2, from computer to the HMI, yes, and then we can create the program from here, from the PC, and then download to the PLC, and we can also design the screen HMI project and then download to the HMI also. Okay, so this is just concept of the Modbus RTU connection that we will test step by step. So let everyone follow me step by step. Yes, let's go. Okay, so first we need to use this one. Yes, but before use this one, I would like to back to the slide for explain of the Modbus. Yes. Okay, so let's continue with two slides. Here is the basic of the Modbus RTU. and here is the address of Modbus, yes, that we will use. Follow this step, yes. So if we push F1, we open the step 7 microwin smart and we type Modbus, we will see this manual operation Modbus. So we can read and follow this step, yes. And then go to the next slide. Here is the address of the Modbus also, yes. So we can read. And for part 1, I will send the data from CPU 1 to CPU 2 via IB0 to QB0. After that, I will send the data from CPU 2 to CPU 1 with the IB0 to QB0. Okay, so totally 8 bits sent from CPU 1 to CPU 2 and then 8 bit from CPU 2 to CPU 1. Okay, and here is the parameters, yes, that we will learn together. So first we can go to the Modbus library. If we install the step 7 microwin smart software, we will got the library of this Modbus. Okay, so I would like to explain the blocks. Yeah, the first one is enable, yeah, block. We can use always on SM0.0, and this is the mode. It means that if we turn on, we enable the mode of Modbus. Let's see here. On it means that enable Modbus mode. Off it means that use the PPI module. Okay. Okay, so let's go to baud rate. It means that transmission rate. Normally we will use the 9600, and here is the priority. So when we set 0, it means that no priority. We choose 1, it means that OGD priority. We use 2, it means that event. Yes, so we will use 2. And here is the port 0, it means that RS485 integrated in CPU. When we choose 1, it means that RS485 or RS232 located on the optional CM01 signal board. Okay, and here is the timeout. Actually, normally we use 1000. It means that 1000 millisecond and equal 1 second, right? And here is the done. Done, it means that when the block is true, it means that it will done. And here is the error. We have a lot of error. 0, it means that no error occurs. 1, it means that invalid priority type. And then we have many error that we can check if the status show. Yes. So let's go to next step. I will explain first before we create the program. Otherwise we don't understand and then we cannot do it. Okay, and then we will go to the Modbus message. So the first one is EN, it means that enable. Yeah, and first let's use the clock memory SM0.6. It means that 1 second on, 1 second off. Okay. And for the slave, it means that the parameter slave is the address of the Modbus slave device. Okay, H it means that we use the Modbus slave address number H. And 1 it means that read write, so we can write the value. Yeah, we choose 1. And address here, so it is the address of Modbus address here. It will start from 01 to 9999, yes, for output coils. So we will choose 1 because we will send 2 output, right? Okay. And for another type, we can see here, follow this step. For count, it means that the parameter that assign the number of data elements to read or write in this request. Okay, let's see here. So we need to follow this step. After that, we will go to the library memory location. Yes. So memory location is very important that we can set, because when we use the block Modbus, we must assign the address to be ready. Yes. So I will assign VB5000. Yes. And this is a step for assign the memory. The first one, let's go to file. Second, let's click memory. And then third, we can fill here with VB5000 and then click OK. Okay. And then after that, we will download the program to the CPU1. Yes, finish for CPU master. And the next step, we will go to the CPU slave. It means that CPU2. So first we can drag and drop the library of the Modbus block here. And we will fill the address. Yeah. Follow this one. And we will insert the Modbus slave. Yes. And then we assign the memory allocation also with VB5000. And then we will download the program to the PLC2. Okay. So this is step 1 that we will follow this slide. Yes. So let's go. Okay, so first let's go to open step 7 Microwin Smart. Right now I will use version 2.5, yes, that I already installed in my PC. And if we already install in our PC, we will got the library. Yes, many library for this Modbus. Yeah, we can use Modbus RTU, Modbus RTU master, RTU slave, TCP IP, yeah, TCP server. Yes, and then we can use many function, yeah, for this library. So version 2.5 is many library that we can use. So let's go to our concept. So let's go to the slide. I already convert to PDF. So the first one I already explained. Yeah. So we will send the IB0 to QB0 of PLC2, right? So let's go to this step. The first one, we need to insert the Modbus control, right? So let's go to library tab, and then let's go to Modbus master, right here, and then drag and drop the block to the main program. Okay, we will go like this. So the first one here should be enabled, right? Okay, I will zoom. So the first one we can enable with SM0.0. It means that always on. Yes. And for mode we can use the always on also, right? Follow this step, because we need to enable the mode of RTU, right? So we can go to SM0.0, yes, or enable the mode, and we can use the baud rate, right? So baud rate, actually we use 9600, and priority we will use 2, right? Here we will use 2. It means that even, yes. So I will put 2. And for the part, right, here is the part, so we can follow here. Part I will use 0. It means that RS 485 integrated in the CPU, yes. So I will use 0. And for the time, it means that time out, right? So I will use 1000. It means that 1 second. So 1000 millisecond, right? And for the done and error, we can use another memory, example M0.0 MB1, yes, example like this. And we need to insert for Modbus message, right? So let's go to Modbus message. Okay. And the first one here, we can enable also, right? So we can follow here, enable. If the block is done, so we can enable the block Modbus message, right? Okay. So I will use NO and then copy from here. Yeah. Copy from the done. Yes. If this block done, it means that finish for initial, and then we will go to block number 2, right, for Modbus message. And first it means that first initial, so we can use the clock memory. Example, we can use SM0.6. It means that the clock scan, right? So we can press F1 and then SM memory, special memory, right? So SM memory, we can read many SM memory that we can use. Okay, let me find the SM0.6, right? SM0.6, it means that clock scan, right? Okay, so we can use clock scan to scan the block, yes. So I will use SM0.6 and then PAL because we need only first, right? So this one we can use positive edge, yes. And for the slave, it means that slave address. So example H, and here is the read write. If we put 0, it means that we cannot write. So right now we put 1 because we write the memory to the CPU slave, right? And here is the address. I can use 1. For count it means that the assign the number of data element, right? Okay, so we can count each bit. Example, if everyone would like to send two bytes 16 bits, right? So we can enter with 16 bit. So right now I will use only 8, right? So I put 8 1 byte, right? And here is the data. So data will start from IB0, yes. And for that I will use M0.1, MB2, yes. Sorry, MB2, yes. So this is the data that we will send to the slave, right? So we will insert one more for send or got the data from CPU slave, right? So we will insert one more block for Modbus message. Here we can enable, yes, we can enable, follow my slide. So this one I will use as M0.0 also, yes. So M0.0, it means that the block number 1 is finished here. And then block number 2 will turn on, right? So I will use N, it means that negative H. Okay, so I will use this one, yes. SM0.6 also, right? It means that the clock memory scan, yes. So I will use NO and then SM0.6, and I will use negative H. And here is the slave H also, right? And retry, it means that we got the data from the CPU slave. So we no need to read, no need to write, right? We need only read. So I will put 0. And here is the address. Let's see here. The address is 10,000, right? 10,001, yes. So I will put address 10,001 and count. We will got 8 bits also, yes. And the data is should be 0, right? And this one we can put M0.2, MB3, yes. So that's all for create the block. But when we compile the block, we will got error, right? Let me test. So I will compile, and we will got the error is 135 error, right? 135 error, because we not yet put the memory allocation to this block, yes. So first let me go to setting the CPU, yes. example, the CPU SR20, I will go to communication and then I will set the IP address, right? And for the CPU one, we can follow with this step. Yes, 192.168.1.2.1, right? .2.1 first, and then go to stand up. I will start run the CPU, and then I will assign the memory allocate to the block, right? Otherwise we will got error. Yes, many error. So let's go to file and then go to memory. Yeah, here click, and then I will put VB 5000. Yeah, example VB 5000, and then click OK, and then let compile again. We will got error 0. Okay, so good. And then we will save the CPU 1 or CPU master. Yes, so this one, Modbus RTU S7-200 Smart project, and this one for CPU 1 or master, right? So master. Okay, for RTU master block we already created, right? And then we can command a little bit here. Example, initialization session of Modbus. Okay, and this one, send IB0 in bin that 1 byte, right? One byte I0.0 to I0.7, right? To PLC 2 or slave, right? Okay, and this one should be got QB0 to QB0.7, right? 0.0 to QB0.7 from PLC 2. Yes, then we can save, and then we will go to create the block for CPU slave, right? Okay, let me minimize, and then open one more, step 7 microwin smart. Yes, and we will create the same procedure that I already showed in the slide, right? For CPU 2. Yes, here. So we will use the Modbus initial, yeah, for slave. This one I will minimize and then go to slave. So for initial, initialization of Modbus block, and then we will go to library and then go to Modbus RTU slave, right? Okay, click here, and then we will use this block, drag and drop. Okay, so first is enable, right? But enable we will use only one scan for enable, right? So SM0.1. Okay, SM0.1, it means that first scan when we turn on the power of PLC or we start the CPU, it will first scan on, yes, and then off, on only one scan, right? And for the mode, we can use another mode, example mode 1, yes, we will use mode 1, address 8, right, and the baud rate the same, priority 2 also, port 0, delay 0, 8 mark 0 mark AI 0 and VB 0, right? Okay, so we can follow my slide. Mode 1, address 8, baud rate 9600, priority 2, port 0, delay 0, mark IQH, mark AI 0, and this one 0, right? And the whole link register will start from VB 0, and for done we can use M0.0 MB1, yes, and then we will use one more for Modbus slave, right? Okay, so Modbus slave, example M0.1 MB2, yes, and don't forget put the SM here, should be this one, right? SM0.0, it means that enable, right? So we can enable with SM0.0, and then if we compile like this, we will got error also, yeah, error 74, yes, because we not yet put the memory allocation, right? So let's go to file and then go to memory, and we can put VB 5000, yes, and then we can compile again. We will got error 0, right? Okay, then we can save, and this one should be CPU 2 and slave, right? Okay, and go to the CPU property communication, set the IP address with 192.168.2.2, right? Okay, and then we will go like this. Okay, I will open like this. then zoom out a little bit. Okay, one more. We can do like this. Okay, I will zoom out a little bit. Okay, so this is CPU 1, it means that master. Here is the CPU 2, it means that slave. So we will download one by one to the CPU, right? So before download, we can go to set the IP address of our computer to be the same rank of the CPU, right? For CPU 1 is 192.168.2.1. CPU 2 is 192.168.2.2. So I will set my computer IP address with 192.168.2.253, yes, and subnet mask 255.255.255.0, yes. Okay, and then we can ping for test. Go to command prompt, so cmd, we can run as administrator. Then we can use cmd ping 192.168.0.2.1. Yes, we can ping for CPU number 1 and one more. So ping 192.168.2.2. Yes, we can ping also. So we can connect, right? So we will download the master program to CPU number 1 and slave program of Modbus to CPU number 2. Okay, so I will go to communication and then choose the network that I already connect to the switch. Yes. Okay, then we will detect two CPUs of PLC, right? The first one is CPU number 1. I will choose this IP. Actually, we can click plus line and then we can see the CPU is blink. Yes. Okay, we can stop and then we can choose for download. Then download button and then I will download the program to master CPU. Okay, and then we can online and start the CPU. Yes. Okay, so I will start the CPU number 1. Yes. Finish. And then we will download the program to CPU number 2, right? So let's go to communication and then choose the network driver. Yes. And then I will choose the CPU number 2, right? 192.168.2.2. We can click here to plus the LED. Yes. And then we can click OK. And then download to the CPU. Finish. And then we will start the CPU 2. Yes. So if we start the CPU 2, let's see the condition. Here is 1, rest. It means that done. So if I stop the CPU, let me stop the CPU. Okay, stop the CPU. Start the CPU again. Yes. So we can test the data. Yes. So first we can go to the status chart, right? I will choose the data. So this one should be IB0, right? And this one should be QB0, got data from the CPU slave, right? So I will use binary. Yes. And then here for CPU slave, I will use status chart also. Yes. And here should be QB0, right? And this one should be IB0. I will use with the binary also. Yeah, view as binary. So we can online. Yes. And we can online here also. And I will force the signal from here. Example, I will force with the 8 bit on with 8 bits, right? So basically we can use calculator. Yeah, if we would like to turn on 8 bit, we can use binary, right? Click binary and then we can use 8 bit. Yes, 8 bit. So convert to decimal, we will assign with decimal 255, right? So I will force 255 here and then click here for force the signal. Yeah. When I force the signal, let's see QB0 is turned on all and the output is turned on also. Yeah, let me show. Okay, let's see the output of PLC slave is turned on. Yes, 8 bit, and this is the CPU master. Yeah, that connect with the cable. Yes, here. So it works properly from CPU master to CPU slave. Yes. And if we would like to force the signal from CPU slave to CPU master, we can write like 255 also and then force the signal. Yes, it will turn on 8 bit also. Yes, let me show. Yes, let's see the CPU master is turned on 8 bit also for output. Yes, so it work. So the communication between CPU master and CPU slave is work perfectly. So I will write 0, it means that 420 turn off, and then here unforce. Yeah, and this one I will force to 0 also. Yes, and then unforce. Yeah. So we can also create the HMI for start send the data from here to here also. Yes. So let's create. Okay, this is just example, so we can create send data from PLC 1 slave, right? Sorry, master to PLC 2 slave. Yes. So if we would like to control via HMI, we can follow like this. Yes. So example, I will use M0.0, right? We already use, right? M0.0. So example, I will use M 1.0. Yes. And then let's turn on the output, right? Turn on the output. And we also use the push button for test also, right? Okay, let's test together. So here I already put and connected the cable to the push button. So if I enable the PLC example, the bit number 0, yes, let's see the PLC slave is turned on also if I enable the input of PLC master. Yes. And for bit number 2, yeah, I will push the button. Yes, on, and then see here is on also. Yes. And this one on, and here is turn on. Yes, I will hold the signal from the input, and let's see the output. Here is turn on. Yeah, I will release, and then let's see is release. I will turn on one more input. Yeah, and let's see the output of master is turned on also. Yes, so it worked perfectly. And if everyone would like to show the status of the output on the HMI, we can also create the HMI. So let's open the WinCC Flexible Smart version 3, and then create the new project here. Right now I will use Smart IE 700 IE V3 here to be the same with my hardware. Yes. And then we will create the communication by link to the PLC 1 and PLC 2, right? So example, I will create the connection for master CPU, and I will connect to the schematic S7-200 Smart, and I will use the IP address of Ethernet, yeah, because we link via LAN cable, right? So 192.168.0.2.253, right? It is the IP address of my PC. And for this one, 192.168.2.1, right? PLC 1. And for PLC 2, we can also use slave, right? This one should be slave. And connect with the PLC Smart also. And this one is the same, but this one should be changed to 2. Yes. So we need to show the status of output of PLC 1, right? So we will create the text. So for CPU 1, this one should be Q0, okay, PLC 1, or we can write master Q 0.0. Yes, it is Boolean, right? So I will choose Boolean, and then it will start from Q 0.0. This one should be bit 1, right? Master CPU bit 1. This one should be 0.1, right? Q 0.1. Master CPU bit 2. And we can choose like this. Yes. Okay. So one more, right? 0.7. Because totally 8 bits, right? So from Q 0.0 to Q 0.7, right? And this one we can try with the master bit 3, master bit 4, master bit 5, master bit 6, master bit 7, and master bit 8, right? Okay. And we will show the status of CPU slave also, right? So we can start from slave Q 0.0, and this one I will choose the connection for slave CPU, right? It's very important here. If we choose the wrong connection, we cannot control to another PLC, or we cannot see the status from the PLC, right? So I will choose slave, and then it will start from Q 0.0, yeah, and this one should be slave CPU bit 1, right? Then I can drag and drop like this. Okay, delete 1. Okay, then I will got from Q 0.0 to Q 0.7 of PLC slave, right? Okay, so this one should be copy and then paste here. Q2, paste here also 3, 4, 5, bit 6, bit 7, and bit 8, right? Okay, and then we can save the project. Okay, I will save to Modbus, right? Okay, so Modbus HMI, yes, and then I will go to separate the screen, yeah, the same as the previous video. So I will separate the screen like this. The right side is for PLC 2 and the left side is for PLC 1, right? Okay, so I can go to property and then change this one to be bigger than before, right? And for the background I will change to this color, yes, and this one I will use green color for separate, yes, and then I will use the text. Okay, the text I will use the PLC 1 or PLC master, PLC master output status, yes, and I will use the text I will use yellow color, and then I will use bold, and then I will increase the size to be maybe 17, yes, like this. And for this one should be a status of PLC slave, right? So I will rename this one to be slave, yes, okay, and then we will show the status of the 8-bit of PLC master, right? So let's go to create like this. So bit 1, example bit 1, bit 2, bit 3, bit 4, and then we can make us like this. Okay, and then I will copy 4 more, yes, and then I can change color to be red color when status off, and then green color when status on, right? So I can copy for slave also. Okay, like this. Okay, like this. And for this one we can write example bit 1, bit 1 until bit 8, right? So bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7, bit 8, right? So I will rename this one to be bit 2, bit 3, bit 4, bit 5, bit 6, bit 7, and the last one for bit 8 for CPU master. So I will copy to be the same as the CPU slave, right? Okay, good. Like this. I can save again. And then we need to show the status, right? So here example show the green, it means that turn on. Yes. So let's go to property and then go to animation and choose master status Q0.0 until Q0.7, right? So I will choose master Q0.0 and then change the color. When status 1, it means that it turn on. I will change to green. Yes. This one also master Q0.1. I will use bit, and then when 1, I will change to green. This one also Q0, sorry, master Q0.2, 1, and then change to green. Master Q0.3, 1, and then change to green. Master Q0.4, when it 1 status on, I will change to green. Master dot 5, right? When 1, I will change to green also. Master dot 6, right? When 1, I will change to 1, green. This one master 0.7, right? The last one. So we can 1 and then change to green. Okay. And then for the PLC 2, yes, PLC slave, we can also use the slave Q0.0. When 1, I will change to green. Yes. And for this one, we can go to slave Q0.1. We can do the same. Yes. This one slave Q0.2, right? Change to green. This one should be slave Q0.3, right? Okay, so we can for bit here, this one Q0.3 and this one Q0.4, right? So slave Q0.4, when status 1, I will change to green. This one slave Q0.5, change to green. Slave Q0.6, I will change to green also. when the stator on. Yeah, the last one Q0.7 1 I will change to green. Okay, so that's all, and then we can save, and then we can simulation. Yes, can simulation before download to the real HMI. Okay, and then we can go online with this PLC. Yes, and then go here. So no bit on, right? So if I will for the signal, yeah, example I force 8 bit, so 255 force. Yes, let's see, 8 bits is turned on, right? So this one why not turn on, not green? Let me check again for Q0.3. okay, this one, right? Go to property again. Oh, this one should be changed to green, right? Okay, right, and then we can save and then simulation again. Okay, so it green, so simulation is green, and then we can for 0. Okay, and then we can unforce all, and for PLC slave we can also test. So I will choose 255 8 bits, right? Force, sorry, should be force here, right? Cancel all force, and then I will force here 255 force. Let's see, the status of PLC master is turned on also. Okay, so I will remove force. Yes, and we need to download the project to the real HMI, right? So but before download the project to the HMI, I would like to explain about how to setting, because here is the HMI Smart 700 EV3. We communication by using the LAN cable for download, right? So first, let's go to set up the IP address on HMI first. Follow my slide. Yes. So let's go. So first, let's go to transfer tab, and then we need to enable all these options, right? And then press OK, and go to the Ethernet. Yes, and we need to set the IP address of the Ethernet, because we use the LAN cable for communication between our PC to download the project to this HMI, right? So let's go to specific IP address. So I will put 192.168.2 example.3. Yes, and subname is 255.255.255.0, and then click OK. Yes, and then click transfer. Yes, and then let's go to our PC to transfer the data to this HMI. Yes, because we already created, right? So first, let's choose the command from, ping the IP address that we already setting on HMI, right? And we already connect the LAN cable from my PC to the switch and from the switch to the HMI. So we can test with CMD and then ping 192.168.2.3. It shows like this. It means that the communication cannot communication between our PC to the PLC, right? So let me check the LAN cable again. And then we can ping again. Yes. Okay. So right now we can connect from our PC to the PLC and HMI, right? So we can download by press this button and then fill the IP address here. Yes. So the IP address of my HMI is 192.168.2.3, right? And then please download. Yes. Yes to download to confirm. Right now it finished downloading, right? So we can online. Okay. And then we can test it, right? By push button. So if I push the button here, yes, let's see the HMI of PLC slave is show, yeah, for bit number 2, yes, and the PLC is show bit number 2 also. If I release the button, it will not show also, yeah. So if I push the button number 1, yes, button number 1, the input of PLC master is turned on, and then the output of PLC slave is turned on, and the HMI is show green also, yes. So if I test the input of PLC slave, if I turn on the input, let's see the output of PLC master is turned on, and then let's see here the lamp is turned on. Yes, I will enable one more. Yes, turn on also. Yes. So if we force the signal, yeah, let me force the signal from the computer, and then let's see the status again. Yes. So I will go to start 1 and then for this signal to be 255. Yes, turn on. And then for PLC slave I will force also. I will force 255 and it will turn on all. And let me show the status on the HMI. It will green on, right? Yes, let's see here, it green all. And the PLC is green also. Yes, PLC is turned on all for output for both PLC slave and PLC master. Okay. Okay, it turned on off. So this is a part 1 about how to communication and link the data from PLC S7-200 Smart to S7-200 Smart by using the Modbus RTU for communication. Okay. And in the next video, I will show the part 2 about how to link data from the PLC S7-200 Smart to PLC S7-200 Smart also by using the analog signal. Okay. And I will go to use the HMI also on the next step, next session for part 2, and then link to the PLC by using this HMI. Okay. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye.